Are now recording. Okay, so we are going to talk about shell scripting this morning. Yeehaw! So if you get a job working as an administrator, it's going to be imperative that you're able to do some shell scripting. Shell scripting is how we automate tasks. If you have a job doing this type of work and you can't write a script to do the job for you, then you're probably not going to have that job for a long time. And this same skill will serve you whether you're doing network admin, working with Cisco routers, or whether you're doing Unix admin. If you're doing administering Windows systems, the same thing. You need to be able to write batch files and scripts to automate tasks. If you have to set up 1,000 users, nobody is really likely to pay you $35 an hour to sit there and enter each one manually. You have to be real. That is not going to happen. So, what are you going to do? You're going to write a script. The first time you do it, yes, you may just do it manually and work through all the steps. You're going to need to do that so that you know how things work. But once you've done that, then you should be able to sit down and write a script. Once your script is debugged, every time you have to repeat that particular task, you run the script. So at this point, you know, your boss calls you in and says, hey, I need you to do this, this, and this. And you look at them and you go, oh, that's going to take me a whole week. And then you go back to your office, you run your script, pull out a comic book, pour a nice coffee.
Then he comes, sees you sitting in the break room, and then he's like, oh, don't worry. I'm waiting.
I'm working on it. I'm thinking about it. So, or you work your second job, right? So you go back to your office, you got your script running, doing the task, and do some work for somebody else. Maximize your time, like a professional. So, there's a level of scripting, and when you're finished CITX 2210, are you going to be the world's expert on scripting? No. But will you be able to construct simple scripts? Yes. So we're going to be doing some scripting today. I've got some exercises. Maybe you'll want to work in groups of 2 or something doing those exercises, because this will start to tax your knowledge now. You now know enough about the system. You know enough about Linux that I can start making you use what you know in order to accomplish desired goals. Up to this point, we've been working with a bunch of disparate different concepts. So the first script that we have, and I guess I should log in remotely. And where did I put it all? Here we go. So let's look at this. So this particular script, Get back to the beginning of the file. Just think, by the end of the morning, you'll be able to do all of this and understand what you're doing. So this particular script that I've got up, the actual script runs from here, these couple of lines, is essentially an equivalent of a shell script. And if I run the script, all it does is print out the date. Very, very simple case. So you'll be writing some scripts later that 2-3 lines over the next couple of weeks that do things like start web servers, stop web servers, and perform different kinds of tasks. In this case, I have echo, which you've already seen. This is just a shell command. Uses the -n option. If you're wondering what that is, you just go man echo, and it will tell you what n is. Do not output the trailing new line. Okay, so I have a file here called today. So let's open that up in VI. And here is my script. Very simple. Echoes the date. So today is, then it has the next, it uses the date command. So both the echo part, the echo, and the word date are keywords. And date here is included in this string. So /, this is not in my path. The date today is June 7th. Now, if you're wondering, what does that mean? Do not output the trailing new line. Why don't we go into our script and remove the n. And what that's actually doing is that at the end of this line, there's a new line character, which means it's a carriage return. It means return the cursor back to the next line and line feed it. If I run the script again, I'm sorry? Oh. Do you see the difference? In the first case, it printed it all on one line, and in this case, it prints it on 2 lines. That's what the -n option does.
So the -n stops it from making it a new line, right? That is
Yeah. Okay, so when we run a script, it's the kernel's job to determine what shell to use. Now, we have actually got a choice. We can actually choose what shell we want the script to run under, and we would do that by actually modifying our script or by putting that into the script. So if I open up my file, whoops, and I go into insert mode, and I go hash bang slash bin slash bash, that means that my script will run under the bash shell. In other words, what I'm doing is I'm opening up a new shell. And when I open that new shell, my script is going to be passed to it as a parameter. So I run my script now. Absolutely no different than the first time I ran it, except I've defined what shell it's going to run under. So here's an example. Hash, bang, bin, corn shell. Otherwise, we're running under the bash shell or the Bourne shell. The bash shell and the Bourne shell are essentially the same thing. Bash is just the born again shell. So when I create a script, the script has to be executable. So if I go to my command prompt and let's create a script that says, let's call it list. And I go into the insert mode and let's say hash bang slash bin slash bash. And let's make this a one-line script, very simple, ls-la. So I go /list. Now something you'll notice is when I use the tab, the autocomplete, it doesn't exactly. And that's your first indication that you've forgotten to do something. So if I finish typing this in, it gives me a permission denied error. I need to set the permissions so that I have executable permissions on this file. So now I run the script and it works. So it's very, very important. If you forget to set the script to executable, it's not going to run for you. Now it is going to give you an error. It says no permission, you don't have permission. So that should be very, very obvious as to what's going on. We can use all of our different system variables from within a shell. So, or from within a script. So we have some, what's our home directory, what's our path, what's our prompt. So just to refresh, echo. And if I use PS2, PS12, that's a new one. Gives me my And these are just different user prompts that are available. If I look at the home or the path, gives me my home directory. And the same thing if I was to echo the path, it's going to give me my execution path. So all of that's available from within the within your script. Now I give you a fairly complete list of system variables here, or at least enough to get you started. You need to realize that not all of these variables are available on every system. The Unix, Linux environment is very, very generic. So you will find that different variables are available in different formats on different systems that you might work on. Okay, some built-in variables. And you'll see these used later. So the $sign with the @ sign, the $sign, and the hash value. We can use these to take command line arguments. So if my script requires the user to input something, then I need to be able to access those. So in C, if you're programming in C, you have argc and argv, one of which is the number of command line parameters. The other one allows you to access a specific parameter. So I'll give you an example of a command line parameter. You use these all the time. There's no real big mystery to this. I can type ls, which is my command line instruction. I could type ls-l. Now what have I entered? A parameter, exactly. So what does that allow me to do if I go back to this? These allow me to get at those parameters. So I can write scripts that will actually allow me to enter parameters from the command line so that I have more control over my script. The Unix, Linux operating systems are designed to be extensible. So the idea here is that when you go to work with a system, after you've been working with it for years, that system is your system. You have actually built that system into something that's very customized to your specific application. How are you going to do that? You're going to do that by writing scripts, by modifying what's running on the script system. You're going to write programs. All the libraries are included in the operating system. They're very easy for you to access using a C compiler. So you can write programs in C. Maybe you don't like the way ls works. Write your own version. That's power.
So you're working on like a machine for years, and you make it your own, blah blah blah, and then you move on from that company, and somebody new comes in. Would they then have to read over all of your scripts that you've written for it in order to?
You should be documenting as you go along. A lot of organizations will have a process so that you document what you do, so as you modify. But at the end of the day, if you think about it, if I'm working for company XYZ and I decide to quit and go to work for company ABC, do I really care whether or not XYZ is capable of picking up where I left off or not? Probably not. They're that old employer now. And if they have a hard time picking up after you, they might just ask you to come back and pay you a lot more money.
Make it really complicated.
Huh?
That's why you just make it really complicated.
There is a theory of administration that operates that way. Now we say that ethics, you shouldn't make everything super obscure so that you're the only one who can run it. But at the end of the day, ethics are a set of rules that you live by, and money is good. And this is a free market economy.
What were those ethics you're talking about?
Huh?
So what were those ethics you're talking about? Money is good.
Can you put the script inside a
Good
script
ethics.
and then let it run?
I'm sorry?
Can you put the script inside a script? I mean, like,
Yes, you can put languages inside languages. We'll be doing that. Don't worry. We'll get to that. Okay, so I've got another script here. Called myLS. So let's go back here. Clear screen. And if I run this, so oops. It gives me some information about the directory. If I run myLS and I pass it the parameter myLS, it gives the permissions that are set on the file. You might even take a star. So let's look at this. And we haven't talked about loops yet, but I have something here called a while loop. And what we're going to look at here, really right at the moment, because we'll get to while loops in a minute, is that I'm using ls with an LD parameter, $1. Go back to this line, and what we see is that $sign with a number allows me to access a particular command line argument. So I have $1 in my script. So what is this? This is the first argument on the command line. which was either the name of a file or it was the star, the wildcard. And then I'm using -LD, and I'm using awk to take the first column, right? It's just a matter of putting these shell capabilities together in a way that works. And I use the while loop, which we'll talk about in a minute. All that this loop does is this makes the script repeat the same operation however many times are necessary. So if I go back to this sheet, you can see that I can access. How many command line arguments are there? And what is the list of command line arguments? Actually, before we do that, can we make this run under its own shell? I want this script to run under a bash shell. How do I do that? Hash. We call this a hash. We call that a bang. Hash bang slash bin slash bash. You invoke a shell. You can see all the different files that I've created. These different funny file names are just things that I've created, different classes that I've been teaching. So an expectation would be that you would be able to actually explain how one of these scripts was operating. If I was to give you a script on a final exam, a little script like this, and say, comment this, each line, what is it doing? That would be a good 5-point question. And all I would do is take one of my little scripts out of my repertoire of scripts that I've written and say, here, what does it do? And then the expectation would be that you would be able to understand the function of the script.
What's the NF?
I would have to look that one up, I'm sorry. I forget. Let's run it. Maybe it'll just be self-explanatory. I think it's putting out the next column, but I'd have to man it. I knew when I wrote it. Here's a script called inquire. And again, it works with command line parameters. So we have $ first name, $ last name. The script is smart enough, or the shell is smart enough, to understand that we're talking about two parameters that are being put in from the command line. So let's take a look at this. This is one of the ones I put together yesterday. So I run the script. It says, please enter my name. So I enter my name, Elmer Fudd. It says your first name is Elmer, your last name is Fudd.
Read kind of documents in itself the data you.
Yeah. Read assigns these. Right, we're getting right back to this. Right? And the neat thing is that we can almost assign those parameters as being variables strictly by putting the $ in front of them. Anybody here program in BASIC? In BASIC, you always put a $ in front of it because that meant it was a string variable. Same thing going on here. Simple, right? Read echo, we prompt the user. We say, enter your name, which is prompting the user. And then I have read. So in other words, take the script is going to take the input from the user. It waits for a response. The user enters Elmer Fudd or whatever. And then, when the user hits enter, it prints the two command line or the two parameters that have been entered into the system.
And if N wasn't there, you'd be inputting your first and last name on the same line, right? You have that backwards.
If which?
If N was not there, it would prompt you to type your name on the same line,
Yes.
not on the line below.
Why don't we try it?
Oh, so I had it backwards.
And who am I now? Joe Blow. I'm going to put the N back in. Hmm? Sorry, say what?
So N is don't make a
Don't what?
don't make a new line.
Yeah. Something you want to keep in mind is that these may work slightly differently on different systems that you work with. So these scripts will most likely, all of these scripts will run quite well on my Mac. Chances are I could take any of these scripts, enter it from the command line on my Mac, and it'll run just fine. But it might behave just slightly different. The Mac is running on Unix. The server I'm not using this box, by the way, I'm using a server, because by using my own server, if I need later to make a bunch of the stuff that we do here available to you guys, I can just make a big tar file and make it downloadable to you. Here I can't do that at just any time. In the middle of the week, that hard drive is sitting on the shelf over there. My server, it's there whenever I want it. If I was to give you a script on an exam, there's probably not going to be anything more complicated than anything we've done in class.
I just had one more question about that.
Mhm.
So that when you had, can you just go up a little bit?
Yep.
So when you have that read command, it says, so first name and last name, you're defining in there.
Yes.
So if you were to change those to first, first nam without an e, and then on the next line it was first nam with the $sign, you're still telling it that this is the input, right?
Yes.
That's not a parameter in itself.
No. These are arbitrary.
Yeah. Okay.
These are variable names that I made up to be descriptive. First name and last name.
You're creating variables as you go.
one and two.
Well, I probably wouldn't just use a number
Well, I mean, I know what you think.
because that's going to probably confuse the system. I can't use things like if I use reserved words or I start using numbers in the wrong context, I'm probably going to generate errors that I'm going to have to deal with. But first name and last name,
It's just a word.
yeah. And by the way, notice the capitalization here. We call that camel capping. You never heard the term before? Camel capping comes from the idea that the camel has a hump in the middle.
Yeah.
And so when we do this kind of naming, we have the capital letters, they make those little humps, so we call that camel capping.
Makes sense.
Yeah. You'll find that system administrators are very creative people when it comes to naming things. They got nothing better to do. You're getting the idea that you can spend a whole lifetime learning this. You spend years. This is something you can start digging into tomorrow. In 10 years, you can still be exploring new things. There's something kind of awesome about that. You can be a lifelong learner and the more you learn, the more you do, the more money you're worth. The better your skill set. I know where there's jobs right now. Okay, so wildcards. You just saw me use the asterisk. We've used the question mark previously when we were talking about the shell. Remember we did a little lecture about the shell? You have a handout for that, I believe. Yes? Yes? We talked about I/O redirection. This was something else we talked about in the shell. So we can use I/O redirection within our scripts and to feed our scripts parameters. Okay, so this takes from a file and puts into so standard in from a file, standard out to a file. We can append to a file. Okay, standard in from lines that follow up until a line containing a specified word. We can use arithmetic expressions. So we have multiply, divide, remainder. Multiply, divide, remainder, add and subtract. We have comparison operators. Greater than or equal, less than or equal. This is not equal. Sometimes you'll hear me slip, and I'll refer to a bang as a not, because in programming, a bang is a not. In programming, it's a not symbol. In other words, if this is not equal to this other thing. This is a logical and. Is first name, if first name equals last name and middle name equals street name, do this. So we can have two comparisons, right? If A is equal to B and B is not equal to C, then we do something. So we can combine logical operations. So when we can determine in our script whether or not the conditions are being met to actually allow, because we may not have things, we may not want something to execute unless certain parameters are already in place. In other words, if the system doesn't contain a certain library, we may not want the compiler to run. So we'll have it exit with an error or something like that. Okay, so we can do matching and indexing and find the length of a string. So if I type in, length Dan, it's going to return 3 because there's 3 characters in Dan. Okay, we have conditional expressions, so we can do tests. Okay, so generally, and when we see an expression, we're talking about something like first name not equal to last name. Then we have all kinds of parameters that we can use with that. I'll have an example of using this coming up here. Control structures. The case command. So case allows us to create a menu. That's sort of the neat thing about case. So if I look at this particular example, you're going to see that I have some interesting code here. So we're still not up to talking about while loops. We're going to get there. But look, I have cat, and I'm using this double input redirector. What does cat do?
Displays a file to standard out.
Displays the contents of a file to standard out. What does this double redirector into cat mean?
Up to.
Yes. So this is going to print everything from here to here. Kind of interesting, eh? So we have a program that's going to allow us to do some things. If the user enters a 1, then it's going to print the date. If they enter a 2 or a 3, print the current working directory. If the user enters 4, then exit. So just for everybody, if I go back up, you'll notice that I had that input-output redirector from lines that follow up until a line containing the specified word. Then print your choice. Reads the reply. Sorry?
So for the end of menu script that you wrote,
This is all one script. This is all one script.
yeah, so like cat and then end of menu. So if you don't have the end of menu below the exit, that one is that it has to read end of menu whenever's inside the end of menu. Right?
I'm sorry. I'm not sure what you're... Below my exit?
Yeah, like there's another end of menu below the exit.
I mean, if at the menu, like the script, is
Oh,
where-
yes.
Till end of menu.
Yes.
It reads up until then. And
Yes.
if you take that out, then it won't work.
No. If I take that out, it'll print everything.
They'll keep finding
But
the
then-
end of menu.
It'll keep searching for yes. It may not like that if I take out end of menu.
if the end of menu is another script, then can you still do cat and then? Oh no, then that's different.
You answered your own question?
Yes.
Okay. Echo, your choice. Then read the reply. Then here's the case statement. If you're wondering what ESAC is, case spelled backwards. How do we end a case statement? Case spelled backwards. Have fun with it, right? So, case. So if the user's entered a 1, it's going to run date. If the user has entered 2 or 3, then print working directory.
Bracket means then.
Huh?
In other words, bracket. End bracket means if then.
I'm sorry?
That bracket at the end of 1, 2, 3, 4, you're saying that's kind of like an if statement, right?
You can think of it that way if you want. I wouldn't say that's entirely accurate.
But can you do it without bracket?
No. That's part of the syntax.
More like continue on, I guess.
Hmm?
More like continue on, like 1 and then.
Yeah, and you can have a default. So here's your default, the star. So if the user enters a 5, illegal choice. Yeah,
How come that star doesn't represent the 4, 1, 2, and 3 as well? It's everything. Or is it because it's before it?
because if you enter the 1, 2, 3, or 4, it'll never get to the star.
Okay, those are like explicit.
The star is everything else. Because it'll never execute to the star. If I enter the 1, it'll print the date. Then it'll exit the loop, or exit the case statement, and my loop keeps going until somebody has entered the stop.
What if you put like the star before the 1 option? Would it still do the same thing?
I'm not sure that what you're suggesting doesn't make any sense.
Well, what I mean is like if you're using like a regular command and you use star, it represents any character.
Okay, watch. Watch carefully. I understand your question, and once you understand it, you'll understand that it's not a question.
Okay.
That's sort of what I'm saying here. Is look, we have the case statement. So the user has entered a 1, 2, 3, or a 4. The case statement executes. It looks at reply and it says, was this assigned a 1, a 2, a 3, or a 4? And it goes down here and it looks for 1, 2, 3, or 4, whatever it happens to be. If the user has entered a 3, it goes down, it looks 1, nope, that's not a 3. 2, that's not a 3. Oh, 3! Print working directory. It's done its job. Now, it exits the case command, and it goes back, because there's that loop, it prints the menu again, and it waits for the user to enter a value. So this time the user enters a 1. It goes, oh, 1, prints the date. But if you were to put the star up here, it would never get to the 1. So you would never do that. If you did do it, your code would still run, it just wouldn't run properly. Does that make sense?
So,
Yeah? Anybody else?
So
Once
yeah.
let me tell you guys something. Once you get the hang of what's going on with this kind of thing, it's like video games. Writing these scripts and writing programs is really addictive. Because you get into that cycle of writing code and debugging it and making it work. And it's sort of like trying to win in a video game. Something else that we should look at here.
It's video games.
Huh?
It's video games. Good choice.
Notice that I use a variable called stop and I assign it to 0. And the test in my while is as long as stop equals 0. Watch what happens if I choose 4, stop equals 1.
Yeah.
It comes back up here and it does this test.
So stop isn't even a set variable. You have to make that too.
Yes. Yes.
So that's a command within a command, script within a script.
Sort of.
Sort of.
And that double semicolon is just to prompt it to go back to the start.
That's to signify the end of the case statement. That's all. That just indicates the end of a case option. The done here matches the do here. And then I have what's called a conditional statement in here. As long as this condition is met, keep repeating this loop.
So in a sense, you can actually make it unstoppable.
We call those infinite loops. So here's my case statement. So let's enter a 5. Illegal choice. Prints the menu again. If I enter a 1, if I enter a 2, if I enter a 3, if I enter a 4, and it exits.
It actually is pretty cool.
Huh?
When it works, it actually is pretty cool.
Yes, it is.
That's pretty-
Well, did it not work?
Yeah, it's
Vi case. Vi. So there's my script.
Just one other question. The semicolons. Would there be a difference between one semicolon, three semicolons? Why two? That's
Because that's the syntax.
so if you did one, is that a different syntax?
Yeah.
What does that do?
It's wrong.
It's wrong.
It's wrong. So you don't do it. The condition, the syntax for the case statement is to use two
Would
semicolons.
there ever be a situation where you would want to use one?
Not in the case statement.
Not in the case statement?
just to be clear that if after a while and then stop minus e to 0, if I change that the 0 to 1, then it will keep on repeating itself because the 4 choice of 4 is stop equal to 1.
I'm sorry, say that again.
On the script, after a while, like the stop not equal to 0, if I change the 0 to 1, then this, when I input the choice of number 4, it will keep on.
Oh yeah, I could change this. So I could change the script. So I could make this not equal to 0, and then change this to a 1, and change this line to a 0.
Same thing,
Does it do the same thing?
yes. But then if I accidentally put that before stop to equal to 1, then this whole script will keep on repeating.
Yes. If your logic is wrong,
the whole thing is
then it's not going to run correctly.
Let's say if you forget to make 4, you just get to keep moving.
yeah.
So if I go to 1, whoops, 4,
Is there
And
a
it-
way to get, like, let's say you do make that mistake of you end up in an infinite loop, how do you get out of it?
Control C. So let's change my script back. So because I will probably not remember why I did that. Actually, it'll be obvious to me why I did that, but then the conditional statements. Yes.
Let's see you starting with the variable, but with the stop. Don't you usually start with the dash that's gonna,
I'm sorry?
don't you usually start a script with a dash or with the language that's gonna start with, that's gonna compile
So it's-
We did, we actually went there already, didn't we?
Oh, I'm sorry.
We talked about all that already. There's a moral to the story. Get here on time. Um, yeah, if we want to, we can have it start its own shell. And it's kind of good that you brought that up because I was going to bring that up too. If I want to, I could have this run inside its own shell. Hash bang slash bin slash bash.
Yeah, so
You probably don't need that. You don't put it just on your phone.
It'll start using the shell that's running.
Oh, okay.
Under a script, does an alias work?
In what terms?
Like, let's say you made that hash bang bin bash into an alias, or like you call it Batman script. You just put Batman and then put on top of the script Batman. Does that work?
Maybe. Maybe. You know what? It might. It might. I'd have to think on that. But I don't see why not. It makes sense to me that that would probably work. The for loop. So the for loop allows me to iterate a number of times. And let's just look. And I'm trying to remember if I actually made a for loop for you guys. I don't believe I made a for loop.
that's not fun.
Huh?
My 4.
I did make a my for. Did I make a my for?
Yeah, yes, sir.
My
Yes. I did make a my for. So look what it does. For color in red, yellow, green, do echo one color is, then I go for name, do, and done. For color in red, yellow, green, one color is, then I have for name, and what does this mean? Sorry?
All variables. That's what it specifies.
So what if I go, do you see the difference?
we have the yellow choices here.
Yeah.
And something.
Actually, let's quit VI. And we've got those two examples. So let's just cat by 4. So then you can see the code with the actual execution of the code. Aha.
I think isn't the column means that in red, yellow, green, choose one, then use that as the display name column.
Yeah, well, it's the one that you're entering from the keyboard is showing up second. If. So we have a command called if. If this, then do this. If this, then do this. Else, if this other thing, do something else. Else, do something else. If then. If the student's name is Martin, then reduce grade by 10%. Else, if Martin has a beard, increase grade by 20%. He likes that one. Yes. And we can make those quite long chains.
Can you have an if inside here?
Yes. Oh yes, we can nest them. That's called nesting. You guys understand that what we're talking about this morning, these are very fundamental basics, and that if you actually decide to learn a little bit of C programming or Java programming, a little bit of maybe Perl or Python, then those skills work in conjunction with these skills, because programming doesn't change. Whether it be shell programming or Perl script programming or C programming, the basic concepts don't change. There is such a thing in C, in the C programming language, as an if. There's a case statement. There is a while loop. There's a for loop. We can do all of these things in just about any programming language there is. So the more sophisticated you make your programming skills, the more you can do with the operating system. When you first start out, you do simple things like automating the task, like writing a script that installs Apache for you automatically. Wouldn't be too hard, would it? No, not hard at all. I can write a script that installs Apache. As a matter of fact, I might make you guys do it. Might be a good exercise. We want to spend a certain amount of time here on scripting. It's very, very an important thing. If you can't do scripting, if you can't understand a little bit of the programming language or logic, you will never, ever be a success in this field. It does not compute. To try and do this without being able to do a little bit of programming, I'm not saying be a master programmer. I'm saying without being able to do a little bit, you just can't be a success. You just cannot do the job. So look at what we have here. We have a script that prompts the user enter a number. We read what the user enters, assign that to a variable called number. So if I enter a 5, the number works like a bucket and it's holding the number 5. Then if number is less than 0, then echo negative. Else if the number equals 0, then print 0. Else print out that the number is positive.
Which part of the script actually defines that you can put the value in? Like, when you run this,
Read.
read the read. And you put read over.
Okay. And I should have a myIf here somewhere. Yes. So vi myIf. Here's the code. So let's clear screen. So we have lots of room. Let's cat myIf. Then let's run myIf. And let's enter a 2. Let's run it again. Let's enter -2. Let's run it again and enter a 0. This is cool. This is allowing you to make your, matter of fact, all these conditional statements that we've been looking at, these allow you to give your scripts intelligence. This is how you create artificial intelligence. Right? If the stove is hot, do not touch it. If stove is hot and I touch it, then I get burned. If the car is Honda, do not buy. If car is Ferrari, then buy. Huh? Nothing. I have a friend who owns a Honda dealership, so just don't tell him I said that. He's my bike riding buddy. While. Here's another looping command. While some expression, do. How about until? Okay, so until something happens. Until x equals 5, do this. And then we have a command called trap. Only works in the Bourne shell. And trap is a command that allows us to look for a particular type of a signal. Okay, so let's go here and run trap. What did I call that, by the way? Run.
Myra.
My run. Do you see it?
Yeah.
Okay. So dot slash my run. And then Control C. And it prints Control C. Trap actually finds what I entered.
Just leave it.
Okay. It just traps Control C. Okay, so we have one final one. And this is a very simple example of a function. And this is a much more advanced programming example. And so what's going on here is this is a function that finds out how many users are on the system. How do I do that is very simple. I use who. So if I go back and I clear screen and I type who, it tells me there's one user logged on from BCIT. Who am I? Who am I? I am root. If I run who and I pipe that to word count, and use the -L option for number of lines, it says 1 because there's one line. In other words, if I SSH to localhost, so remember I'm logged into a remote server. The server I'm logged into is at my home office. So I'm going to log back into that server. Now if I type who, root is logged in on 2 times. So if I type who, and I pipe that to word count, and I count the number of lines, yep, 2 lines. So I log out, I use Control D, that logged me out of one of my logins. So number users which creates a function named users of type number. Okay. This is getting into a little bit more abstract. So essentially what's happening is I have a function called users that is, and this function, the value of this function is being assigned to number. And then I call my function here. So what did we name this? NU.
So this one was necessary to set in batch.
Oh, I put that into the script because this only runs this actually this will run in I think in other shells as well.
It's just sort of making like a little process to run the script, and asking itself to run it.
I'm sorry?
Is it basically just like creating a little process in the script and then asking the script to run what it just defined?
So I said again,
It's okay. So the function is just creating like a little process in the script.
Yeah.
And then by calling it, you're just telling it to do what it defines.
Yep.
Are there like the curly brackets? I see like some stuff has it, some stuff doesn't. Is that just because you're...
Yeah, I just created a function called number underscore users.
Yeah.
And here I call that function. This is where it's called.
Yeah.
The function is defined here. This is where it's called. Return 0 means this function doesn't return anything. See, if I had gone my value equals number users, then I would have had to return the number that was generated by this line. So I could have gone return who pipe to WC, put that all in brackets, and not to worry about that at this stage. You just want to know that this stuff exists. What are we at time-wise? You guys, it must be just about time for you guys to take a break.
Just wondering, do we get copies of the notes for that?
Copies of the notes?
Absolutely not. You're writing them down.
Yeah, I'm going to give you copies of notes. Don't worry.